In this video, we're going to discuss how to calculate an acceptable class width in order to create a frequency distribution. So let's try to organize this raw data, which is a set of waist circumferences for men, into a frequency distribution that has 5 classes and starts with a lower class limit for the first class of 31, all right? So the numbers here range from 31.5 up to 45.2. So let's go ahead and start our first lower class limit at 31. Let's try to put it all into 5 classes because there isn't that much data here. And let's see what we come up with. All right, so let's remember our goal. We want to have 5 classes and we want to start our first lower class limit at 31, right? So we know down here we're going to start with 31 and go up to something for our first waist circumference measurement, right? All right, so 5 classes. Here's what we're going to do. Once we know what number of classes we want to use, and again, that's typically given to you, or you can use the sort of guidelines discussed in your class on how to choose that. But once you know how many classes you're going to need, then you form this simple calculation. You're going to determine the range. And the range is just the high number in the data minus the low number, right? So high number minus the low number. Okay, so what is that in our example? Well, the high number in our list, if you look back, since this was put in order, was 45.2, and the low number was 31.5. So we had 45.2 minus 31.5. Okay, so let's go ahead and subtract them. So we'll do 45.2 minus 31.5, and that should give you 13.7. And there you have it, 13.7 is indeed the difference. And once you have your range, you're going to take that range and divide it by the number of classes, and that will give you a lower bound for your class width. In other words, your class width is going to be a number that's greater than or equal to this result, the range divided by the number of classes. So in this case, that range is 13.7. It'll be divided by 5. And when we do that, we get the answer 2.74. All right, that number is probably not the number we're going to use. First of all, our data only has one decimal place. It's 45.2 type number, 31.5. It doesn't have like 31.57 or something, right? So it doesn't go out to the hundredths place, so we want to keep it to the tenths place probably for the class width. And then in general, we prefer not to use decimals if we can avoid it, so we probably want to use something nearby that's convenient. So I'm going to go ahead and call this 3 instead. And it's not that you couldn't use the actual number that comes out all the time, but most of the time it actually doesn't work. So our goal is that the last class that we create contains our largest measurement. So in this case, our largest measurement is 45.2. We want to make sure that that fits in our last class. So let's see if that works. So we're going to use 3, and the way we do this is we add 3 to the 31 here. So we do 31 plus 3, and it gives you 34, and the answer goes below it, not across from it, right? And this is if you want to create class limits. So if you're trying to create class limits, this is how you do it. Okay, so let's add 3 to 34. You're going to get 37. Add 3 to that, you'll get 40. And add 3 to that, you'll get 43, right? Then on the other side, since we're working with class limits, we want to make sure that the upper limit here is not the same as the lower limit for the next class. So in other words, we can't use 34 because 34 would be the same as this lower limit. So what we're going to do instead is use something like 33.9 because that's right up against 34 without actually becoming 34, right? So we're just going to do a little bit less. We'll do 33.9. Now we use 0.9 here because the data has one decimal place, right? This 45.2 has one decimal place, 31.5 has one decimal place. So all of the numbers are rounded off to the tenths place in the data. So it's okay to have limits that go out to the tenths place. So 33.9 is perfect. Now if I add 3 to that, I will get 36.9. Then if I add 3 to that, 39.9. And if I add 3 to that, 42.9. And then add 3 to that, and I finally get 45.9, which is perfect because that means that our largest data value, 45.2, falls nicely inside the last class. All right, and that means you've done it right. So this 3 is the magic number. If you had decided to use boundaries, right, if you had decided to create class boundaries starting over from scratch, we would have done basically the same thing. We would have started at 31 like the problem requested. We would have done the same adding of 3, right? Add the 3 to every item in the left column. So 31, add 3, you get 34, then 37, then 40, and then 43. Same thing as we got before. However, now you could just end up at 34 for the upper boundary because you want these two to match if you're using boundaries, right? And then it'll just be 37, and then 40, and then 43. And then the only one that's new is we add 3 to 43 to get 46. And those are class boundaries. And once again, we see that 45.2 falls nicely within the last category, so it means these work as well. So whether using class limits or class boundaries, it seems like a class width of 3 is perfectly fine.